Let's look at this final question on our test review. And this question will be similar to the free response question that you'll see on your test. Here in number 10, we do have a little bit of a mistake. It says the average daily high temperature, and that should actually read the average monthly high temperature, because our equation down here has that little M there for months. So we're actually looking at an average monthly high temperature in degrees Fahrenheit for a city being modeled by this function. And we're asked to sketch at least one complete cycle of the function, labeling numbers and units on both axes. Now you do have a calculator for this question, and if you want to type it into your calculator, you're going to get a graph that looks like this. But still we need to make a pretty good sketch of our own with good labels on the axes. So I'm going to figure out my A, B, C, and D before I try to sketch my graph. A, of course, is going to be the amplitude of the graph, which is 23.2. And the D value is this 58.7 at the end. That, of course, is going to be the midline of my graph. I have a horizontal shift of 2. So my C value, we're going to be moving right 2. And the last thing I need to figure out is the period. Remember that the period is always equal to 2 pi divided by the B. And so in this case, we have 2 pi divided by 2 pi over 12. And if I multiply by the reciprocal, 2 pi times 12 over 2 pi, 2 pi's cancel, and we get a period of 12. So with that information, I'm going to go ahead and sketch my axes and label them for the graph. So on the y-axis, we're going to label in degrees Fahrenheit. We've got some pretty weird numbers for the y, those decimal numbers. So we're not going to count off a bunch of units here on the y-axis. I'm just going to mark a line here and label that 58.7. So that's going to be the midline of our graph. I'm going to go up here and mark off. This is going to be, since my amplitude is 23.2, if I add 23.2 to 58.7, we get 81.9. So that's going to be the top of my graph. And then if I subtract 23.2 from 58.7, we get 35.5. And so that's going to be where the low points of the graph hit. Now on the y-axis, I'm shifting right 2, and I have a period of 12. So I think I'm going to count by 2s. 2, 4, 6, 8, 10, 12, 14, 16. So here's 2, and I'm not going to label every one, but just enough to help us with our graph. And my units down here, of course, are months. So I have that phase, that horizontal shift of 2 to the right 2, and so that means right here at 2 is going to be the starting place for the cycle. If my period is 12, that means that we're going to go all the way out to 14. Because 2 plus 12 would be 14. And then I'm going to go ahead and mark off the middle of the cycle just to help us out a little bit with the graph. Now notice that we're sketching a negative cosine graph. This is negative cosine. So my graph is going to start at the bottom here at 2. I'm going to start out down here at a low point, which means by the end of the cycle, I'll be back at the low point, high point in the middle, and then crossing that midline halfway in between those. And let me try that again. So there we have at least one cycle of our graph. Let's move on to part B. In part B, we're asked to write a sine equation that could be represented by the same graph. And I just did that again. So for this, I need to figure out where a sine equation would be starting, what my x-coordinate would be for the starting point for sine. So I'm going to try to sketch in this midline at 58.7, 10, 20, 30, 40, 50, 60. So looks like my midline is about right here. What I really need are these numbers down here on the x-axis. Remember that we started at 2. This high point is at 8, and my low point ending the cycle, remember we finished the cycle by 14. So those were the low and high points on our graph. But what I'm looking for is what x-coordinate corresponds to this point right here. Well, that point is going to be halfway between the 2 and the 8, which would be at 5. And so that means that for a sine equation, my c value is going to be 5. So my sine equation, everything else is going to be the same. So the sine equation is negative 23.2 sine of 2 pi over 12. Here's where we change x minus 5. And then at the end, plus 58.7. All right, question C. In question C, we're asked to determine in which month does the maximum temperature occur. So we just talked about that on the last graph. Remember, my maximum is right here, and that point corresponds down here to the 8. 1, 2, 3, 4, 5, 6, 7, 8. And so that means that max temperature occurs, max temp in month 8, which would be August. All right, last question. Question D is asking which months have an average temperature of 70 degrees. So for this question, we're going to go to our calculator. Hopefully you've already got the cosine equation graphed. We want to also graph f equal to 70. And when we do that, we get a graph that looks like this. And once you have both of those things graphed, what we're looking for here are the intersection points. We want to find what this point is and what this point is. Those are going to give us 2 months that have an average temperature of 70. So to do that intersection, you're going to go to the menu and then choose Analyze Graph and then Intersection Point. And when we find the intersection points, you should find these points, 5.9716 and then also 10.0284. So an average temp of 70 degrees in month 5 and month 10, which would correspond to May and October. Now, I realize that 5 is 5.971, and it sure is close to being the 6th month, but it's still occurring within month number 5. And so we're going to choose month 5, May, and then for the 10, of course, October.